This is the second video for Math 107 for the homework number 2. So these the questions, the next couple questions are a follow-up on the first questions, and this of course is the way people talk to each other. They speak in terms of percent. So let's see if we can translate this. We started off last time, we had a fixed cost of $1,400 and we had a variable cost of $75. That's what it cost us per set to recap these tires, and the price was $89 for a set of tires. Okay, the manager tells you that next year the fixed costs are going to go up by 7%. There's two ways you can do this to find the new fixed cost. You can take the old ones, so you go 1,400, and multiply by, of course you have to change that to decimal, 0.07, and working that out you find out they're going to go up like $98. Then you take that increase and you add it to the other one, so your new fixed costs are now $1,498. There's another way. You can just take the 1,400 and multiply by 1.07. Then you don't have to add anything. The 0.07 gives you your increase. The 1 takes into account the cost, and then you have a cost plus an increase. This is a good shorthand to master. Okay, then he says the variable costs are going to go up by 10%. So we could go 75 and multiply it by 1.10. Alright, so we take 10% of these, add it, and we find out the new variable costs. From that, you can write a new cost function. So it's going to be the new fixed cost, which is $1,498, plus whatever the variable costs are, which is going to be, looks like $82.50 times X. Again, just writing $82.50 and the $1,489 will give you a -1 for this problem. You need to show the work. The idea is, how did you increase the 1,400 to get your new fixed cost? How did you change the variable cost per recapping a set of tires? How did you increase that? And now you write it in the same format. Fixed costs and variable costs are multiplied by X, because the more tires you make, the more costs you incur in that area. So that's what you have to do for 5. Now the question for 6 is going to be a little bit different than the typical break-even analysis. Now you have to compute the price required to put the break-even point at X equal 90. What does this mean? Okay, let me write what break-even means. Make sure I've got a pen here. It means revenue equals cost. Revenue is price times the number sold at break-even would be the fixed cost plus your variable cost times X. Usually we have the price, the fixed cost, the variable cost, and we want to know what X is for break-even. In this case, this is specified, but the price isn't. And this would be something you would think. If you figure you can only sell, say, 100 or 150 sets of these recap tires in a month, you want to make sure that your break-even point is at about 90, so you do have some profit for the month, some gain for the month on and so what you want to do is adjust the price. So here's a way to do your math problems. Again, I like you to do things in an organized fashion. Write the equation you're dealing with. See, I've written that equation. Now go back and substitute the numbers. Price I'm not going to know, but I was just told that break-even is 90, so I'll put the 90 here. I should have put it first, but I'll do it like that just to demonstrate. The fixed costs, $1,498. The variable costs were what? $82.50. And again, I was told that break-even is 90. You see, now it's obvious what to do. Okay? You want to solve for P. The only problem with P is it's multiplied by 90. You're going to divide by 90. Again, you have to divide both terms by 90, not just cancel those 90s off. That's wrong. And then you've isolated P, and this will give you the price that you need to charge for those tires in order to have the break-even at 90. For number 7, you need to solve the following quadratic equation for y equals 25. Okay, what does that mean? That means substitute y equals 25 into the equation and try to find x. So if I put a 25 here, you might think about the quadratic formula. However, you only use a quadratic formula when you have this form: 0 ax squared plus bx plus c. Then you know your ABCs and you can use the quadratic formula. The 25 over here is problematic, so I have to subtract it from both sides so that I've got this equal to 0. I have 2x squared plus 20x, and then I have to take the 104 and subtract 5 from that, which is 9. Oh, what do we get? Okay. And now I need to solve this equation. If I leave the 25 over here, I can't solve it. Right. It's going to be the same now as a quadratic equation. You can solve it using the ABCs. Okay, well, that wasn't exactly helpful. I erased the equation, so I think we ended up with something like 0 equals 2x squared plus 20x plus 79. Now I'm in the form 0 equals ax squared plus bx plus c, and I can make the identification that a is 2, b is 20, and c is 79. The quadratic equation is x is equal to minus b over 2a. And I'd like you to write it this way: plus or minus the square root. Don't write this whole thing over 2a. Separate the two pieces. I'll tell you why in a minute. Now I have to have 20 squared, so I've got b squared minus 4ac. Right. The reason for writing it like that is it's possible, especially in a case like this, where the discriminant, b squared minus 4ac, is going to be less than 0. That means you're trying to take the square root of a negative number. You can't take the square root of a negative number in terms of real numbers, so it is an imaginary number. So your solution is going to look like this, and you'll have your 2a here, and then the I will be here, and that's why you leave the plus and minus in the middle. Also, there's other reasons for it, but then you have your imaginary part over here and the real part over here. When you write it all over the same denominator, you kind of mush that up and you don't get such a good look at it. Okay, so I want you to write it like this, work out the terms. You're going to find this is negative. That means you have to change that to an I, put an I out here, make that be the negative part of your complex solution. All right. Number 8 is pretty easy. Ranges are often written like this. So if, let's say I had some other number here like 10 is less than or equal to, I don't know, 5. Good enough. Okay. Why is it written like this? Let's kind of expand this. If the absolute value of t is less than or equal to 5, then that means what's inside is less than or equal to 5, or it's greater than or equal to negative 5. Alright, because if this were negative 5, you put the absolute value sign on it, it would take off the negative sign. Now I can just solve for t here. And if I have a 3-part inequality like that, I can add, to, as long as I do it to each term. So I've got minus 5 plus 10, minus 10 plus 10, so I added 10 to all 3 sides. So this becomes 5 is less than or equal to t, which is less than or equal to 15. Now I have the range for t. You can do the same for these numbers. Why is it written like this? Okay, because this is the center frequency, or the center range. The middle value is right here. So here is the middle of the temperature range, 10. And this tells you how far you go plus or minus on either side of the middle. And that's why people write it in that form. Okay, here's another quadratic function, but it is in a special factored form. In fact, it is already factored. And I want you to give you this, not so that you go back and do it the brute force way, but that you start looking at the function and picking out what's going on with it. All right, so here is the function. Y is the yield. It's the number of oranges I'm going to get off these off my orchard of orange trees. And X is the number of trees that are planted per acre. So here's X, 378 minus X. Okay, so I want to find the vertex. All right, One way to find the vertex is to realize that the vertex is in the middle between the two roots. There's a symmetry of a parabola with respect to the vertex. If you have I'll just draw the parabola down here. No matter where it is, if you went right down the middle and you'd done a nice drawing, which I didn't do, you fold it in half, it would lie right on top of each other because it's symmetric about the middle. So if I have this point and this point, I know the vertex, at least the h value, is right in the middle between them. So in this case, I want to find these two x-axis crossings. Well, if I set y equals 0 here, well, actually, I tell you what to do here because, okay. If I solve for x, I would find that one solution is x equals 0. The other solution is x equals 378. But since I wrote these out here and I didn't realize I'd changed that before I started telling you about it, let's look at it the other way. Let's put 0 in that equation. So y, when x is 0, is 0. Also, when x is 378, it's also 0. So that drawing here is not representative of this particular situation. So what I've done with these two values, I have found the two roots of the equation. They've been given to you. Where is the h value of the vertex? Remember, vertex is hk. H is the x value, k is the y value. Well, this h value is halfway between those two. It's the average. If you took the first root and the second root and added them together, divided by 2, you would have h. Now that you have h, you can find k. So y, in this case, the yield will equal k when x is h. So you put it back in the equation, work through, and you will find k. Then you can sketch it. Because what you will know is you'll know that the yield, here's your yield, and here's the number of trees you planted. It's 0 here, it's 0 up here, and you know that halfway between was your h. This was 0, this was 378. You put that back in the equation and you found your k, and then you can just sketch your parabola from that.